Hello! As we continue our discussion on wrapping and trigonometric functions, we will focus today's video on coterminal angles and reference angles. In this video, we have two targets. First, we would like to know what coterminal angles and reference angles mean. Second, we would like to use them to find trigonometric function values of angles that are either smaller than 0 degrees or 0 radians or larger than 360 degrees or 2 pi radians but are coterminal with angles that are known to us. First, let's review what we learned from our class discussion. Say we are going to find two numbers, one positive and one negative from the number line that get up to the point -1/2 and square root of 3 over 2 on the unit circle. To solve this, we locate the point with coordinates -1/2 and square root of 3 over 2 on the unit circle. Next, we find the angle whose terminal side contains that point. Since the x-coordinate is negative and the y-coordinate is positive, we know that it must be located in the second quadrant. The smallest positive angle is 2 pi over 3. We can obtain other positive numbers by adding as many 2 pi's as we want to 2 pi over 3. Since we are only asked to find one positive number, we may choose one from among the list, so let's stick with the smallest one, which is 2 pi over 3. Meanwhile, the largest negative angle that has those coordinates is -4 pi over 3. We obtain this by rotating clockwise from the positive x-axis. We can obtain the other negative numbers by adding as many -2 pi's as we want to -4 pi over 3. But since we are only asked to have one negative number, then we stick with the largest, which is -4 pi over 3. Now we are ready to define coterminal angles. Let's examine pi over 6, 13 pi over 6, and -11 pi over 6. They are generated using the blue, red, and green arrows respectively. What do you notice with their terminal sides? Yeah, you're right. Their terminal sides coincide even if they have different amounts of rotations used to generate them. Let me repeat that. Their terminal sides coincide. That's the reason why they are called coterminal angles. Remember that the prefix co means same, so yeah, they have the same terminal side. Let's have another example of that, this time in degrees. Let's have 135 degrees colored in blue, 495 degrees colored in red, and -225 degrees colored in green. Again, they are coterminal angles because their terminal sides coincide. Do you think there's a way for us to find angles that are coterminal with any given angle? Let's say that the given angle is pi over 6. How may we obtain the next positive angle to it, that is 13 pi over 6, the next positive coterminal angle to 13 pi over 6, and so on? Notice that to generate 13 pi over 6, we had to add one revolution, or 2 pi, to pi over 6. If we add another 2 pi to 13 pi over 6, we will obtain 25 pi over 6, which is also coterminal with pi over 6 and 13 pi over 6. This is like saying we add 4 pi to our given angle pi over 6. Did you see the pattern? To obtain the positive angles coterminal with a given angle, we have to add multiples of 2 pi to it. In notation, that is the given angle theta plus n times 2 pi, where n is an element of the positive integers. But can we also find a pattern for obtaining negative angles coterminal with a given angle? Going back to the given angle pi over 6, if we subtract 2 pi from it, we will obtain -11 pi over 6, the largest negative angle coterminal with it. If we subtract 2 pi from -11 pi over 6, we obtain -23 pi over 6. This is equivalent to subtracting 2 pi's or 4 pi from the given angle pi over 6. Did you see the pattern? It is actually theta minus n times 2 pi, where n is an element of the positive integers. But what about if we're dealing with angles in degrees? Well, since 2 pi radians is equal to 360 degrees, we will have to add multiples of 360 degrees to the given angle. We can illustrate this with our example where 135 degrees is the given angle. Adding 360 degrees to it, we obtain 495 degrees. Adding 2 times 360 degrees to it, we obtain 855 degrees. Thus, in notation, we have the given angle theta plus n times 360 degrees, where again, n is an element of the set of positive integers. We follow the same logic for obtaining negative angles coterminal with the given angle. From our given angle 135 degrees, we subtract 360 degrees and obtain negative 225 degrees. Subtracting 2 times 360 degrees, or that is 720 degrees from it, we obtain negative 585 degrees. The next negative angle coterminal with 135 degrees. We follow the pattern given angle, that is theta minus n times 360 degrees, to obtain all negative angles coterminal with the given angle. And here should again be an element of the set of positive integers. You might want to pause this video and take notes before playing it again to proceed. We are now ready to check our understanding. Let's find the two smallest positive and the two largest negative angles coterminal with 2 pi over 3. Let's deal with the two smallest positive angles first. To find them, we have to add the smallest multiples of 2 pi to 2 pi over 3. So we have 2 pi over 3 plus 2 pi, and we get 8 pi over 3. We also add 4 pi to 2 pi over 3 to obtain the next smallest positive angle coterminal with 2 pi over 3. That is 14 pi over 3. To obtain the largest negative angles, we subtract 2 pi from 2 pi over 3, and we will obtain negative 4 pi over 3. When we subtract 4 pi from 2 pi over 3, we obtain negative 10 pi over 3. Let us also have an example of angles that are in degrees. Let's find the two smallest positive and the two largest negative angles coterminal with 175 degrees. First, let's have the two smallest positive angles coterminal with 175 degrees. So we have 175 degrees plus 360 degrees, and we get 535 degrees. We also have 175 degrees plus 720 degrees, and that is 895 degrees. Let's also have the two largest negative angles. So we have 175 degrees minus 360 degrees, and we get negative 185 degrees. Lastly, we have 175 degrees minus 720 degrees, and we get negative 545 degrees. You might want to pause this video again to proceed to the next concept and play it whenever you're ready. So far, we have been finding coterminal angles of given angles. But why do we have to do that? Well, because this will help us to find the trigonometric function values of these angles, no matter how small or large they are. Why is it possible? Mainly because if we know the associated reference angle to any given angle, we will be able to find out its coordinates carrying the signs dictated by the quadrant where its terminal side is located. So at this point, we need to introduce the concept of reference angles. The reference angle, denoted by A sub r of any given angle theta, is the positive acute angle between the terminal side of the angle and the x-axis. Take note that it is the angle formed between the terminal side of theta and the x-axis, not necessarily the positive x-axis only. As long as the angle formed is positive and acute, that is the reference angle of the given angle. Let's illustrate that using angles found in different quadrants. Let's have an angle theta in quadrant 1. Here, theta measures pi over 4 radians. Following the definition of reference angles, if we look at the positive acute angle between the terminal side of pi over 4 and the closest x-axis, the reference angle is also pi over 4. In general, the reference angle of any angle in quadrant 1 is equal to the given angle. Let's also have an angle theta in quadrant 2. Here, theta measures 2 pi over 3 radians. To find the reference angle, we look at the positive acute angle between the terminal side of 2 pi over 3 and the negative x-axis, so the reference angle is pi over 3. In general, the reference angle of any given angle in quadrant 2 is equal to pi minus the given angle. Let's also have an angle theta in quadrant 3. Here, theta measures 4 pi over 3 radians. To find the reference angle, we look at the positive acute angle between the terminal side of 4 pi over 3 and the negative x-axis. So the reference angle is pi over 3. In general, the reference angle of any angle in quadrant 3 is equal to the given angle minus pi. Lastly, let's have an angle theta in quadrant 4. Here, theta measures 7 pi over 4 radians. So we'll look at the positive acute angle between the terminal side of 7 pi over 4 and the positive x-axis to find the reference angle. So the reference angle is pi over 4. In general, the reference angle of any angle in quadrant 4 is equal to 2 pi minus the given angle. Now that we know both coterminal and reference angles, we will be able to find the trigonometric function values of angles in the unit circle. Let's say we have to find the 6 trigonometric function values of 8 pi over 3. We know that it is coterminal with and has the same reference angle as 2 pi over 3, which has the coordinates -1/2 and square root of 3 over 2 on its terminal side. That means that those will be the same coordinates that 8 pi over 3 will have. So the trigonometric function values of 8 pi over 3 will be equal to those of 2 pi over 3. So we have sine of 8 pi over 3, which is equal to sine of 2 pi over 3, and that is equal to the square root of 3 over 2. We also have the cosine of 8 pi over 3, which is equal to cosine of 2 pi over 3, and that's equal to -1/2. We also have tangent of 8 pi over 3, that is equal to tangent of 2 pi over 3, and that's equal to negative square root of 3. Let's also have the reciprocal function values of 8 pi over 3. First, we have the cosecant of 8 pi over 3, which is equal to cosecant of 2 pi over 3, and that is equal to 2 square root of 3 over 3. We also have secant of 8 pi over 3, which is equal to the secant of 2 pi over 3, and that is equal to -2. Lastly, we have the cotangent of 8 pi over 3, which is equal to cotangent of 2 pi over 3, and that is equal to negative square root of 3 over 3. So now we are able to achieve our two targets. We learned how to find angles coterminal with a given angle, as well as use them to find the values of the 6 trigonometric functions using reference angles. It's time for us to thank our references for this video.